Hello, welcome. Let's give answer to this question under logarithm. Given that the function f of x is given as 4 exponent x plus 1 times 3 exponent 1 minus 2x, where x belong to the real numbers. Now we are to determine the value of f of a, meaning replacing the x with a. What will this value be if these x are changed to a? Given that the a itself is given as a logarithm or log 2 to the base 10 divided by log 4 base 10 minus log 9 base 10. Let's see how we can manipulate our way through this. Now, first thing, we can see that this f of x is multiplying. So let's solve it together and see what that product will give us. So let's see. So our solution, we can start by saying that if you have f of x equals to 4, the exponent of x plus 1 times 3 exponent of 1 minus 2x. We are aware that this addition here shows that the base we're doing multiplication. So we can have f of x equals to 4 times 4 exponent of what? X. As in the case of exponent 1, exponent x, since they have the same base, we can add the powers. Then times 3, that will also be the base being 3, the power being 1, the base being 3, the power being minus 2x. So we can have 1 here, then times 3 exponent of minus 2x. Now you can see we are still doing multiplication. So the constants without powers can also multiply, meaning 4 times 3, then 4 exponent of x, then times 3 exponent of minus 2x. We know this will give us 12, right? Then this will still be 4 exponent of x. But in the case of this, because of the negative number, we can have the reciprocal of that, meaning we can have 1 out of 3 exponent of 2x, this very one. So in the case of this, we know 2x is actually 2 times what? X. So we can pick the first one as 3 exponent of 2 times x. Is also part of the properties or the laws of indices. If I have this, the powers will multiply. So 2 times x, that's the 2x. So picking it this way, the bracket will give us what? 9. Then the exponent of x. All this still being a denominator. So times 1 on 9 exponent x. But don't forget, this exponent here can also affect the 1. Because 1 exponent, any number, will still give us 1. So we can write the 1 exponent over 9 or exponent of x, such that the exponent x is affecting 1, is also affecting the 9 from the loss, right? Alright. So in this case, we now have 12 times 4 exponent of x, 1 on 9 or exponent of x. And you can see these two numbers are multiplying and they have the same power. So we can put them together by multiplying them under the same power. So I'll finally have 12 times 4 on 9 all to the power of x. So this will be the final stage. Okay, so now that we have the f of x to be equal to this, we can now equate our f of a. But don't forget, f of a will take the x to be a. Then x is also having a long expression which we cannot afford to put there as an exponent. So let's see how we can deal with that. So now let's see. We can say that f of a should be equals to a variable. So that if f of a equals to the variable, it means we are saying this, the whole of this is going to be equal to a variable. So in the case of that, your f of a of the function itself is going to be 12 times 4 on 9 or exponent a, right? Whenever I see x, the f of x is there. The f of a must be there. And the whole of this is what we are saying equals to p. So now we can deal with this equals to p and find the a, not in terms of this long procedure, right? Good. So now let's see what we can do. So now our 12 times 4 on 9 to the power a equals to p. Let's eliminate the 12 from here by dividing both sides by the 12, right? So that is going to give us 4 on 9 exponent of a equals to p divided by 12. So now we have that. So what do we do? We have p, we have a. So let's take logarithm of both sides and see. So we have the log of 4 on a, no, it's on 9, right? Exponent a equals to the log of p divided by 12, or to the base 10, since this is base 10. So now what do? We know the power comes to multiply. Let's write this somewhere there. So now the power comes to multiply to give us a, the log of 4 on 9 base 10 equals to log of p on 12 base 10. Now let's keep the a and divide by this as a coefficient. So now your a will be equals to the log of p on 12 base 10 divided by the log of 4 on 9 base 10. And you can remember the law of logarithm, where we can rewrite this, because I'm seeing it there, as a division is subtraction. So a will be equals to the log of p on 12 base 10 divided by the log of 4 base 10 minus log of 9 base 10. Do you see that? So now our denominators are the same. If a equals to this, and also a is also equal to this, so we can say this is the same as this. So since the denominators are the same, we also equate the numerator. So this is the same as this. I believe you can see that relation. So now, since a equals to this and a equals to this, we can say that the log of p on 12 base 10 is the same as log of 2 base 10. And you can see both are having log 10, log 10. We can divide through by logarithm to the base 10. And you'll be left with p on 12 equals to 2. So p will now be equals to 2 times 12, right? So p will be 24. But don't forget, in the beginning, we mentioned that let the f of a equals to p. Let's find the value of f of a. And the f of a is p. So we can see that, therefore, the f of a is equals to 24. So the value of f of a that we are looking for is just 24. Thanks for watching. Like, share, and comment. Bye-bye.